Welcome to the How to Solve Federal Agency Data Storage Retention Challenge conference call. My name is Katie, and I will be your operator for today's call. On today's call, we have Jean-Paul Bourgeau from SwishData and Mike Dye from NetApp. I'll now turn the call over to Jean-Paul Bourgeau. Please go ahead, sir.
Thanks, Katie. And welcome, everybody. Thank you for joining us. So we're here really to talk about cybersecurity and storage in cybersecurity and analytics. We at SwishData believe there's an opportunity for everyone to look at some better solutions. And to start with, just tell you a little about SwishData. We're about 10 years old, in fact, 10 years old next month, and we are a federal-specific solution integrator. We have a lot of different specialty areas, but you can see my ode to the mall map where I'm pointing to cybersecurity we're really talking about today. But we have a variety of solutions around virtualization cloud, storage, DR, COOP, many different areas, VDI. But we are really an integration company. We're all about technically sound architecture and making sure that we help the customer A to Z through implementation, integration, and even training and handoff, as well as we like to do ongoing services to make sure that health checks are done and keep things running well. We have clear turnkey engineering services, and we do hold a GSA schedule, a SUIT schedule, and a COCS contract. I'm actually looking at the 2-to-1 engineering ratio, and we recently hired a bunch of people, so we're a little bit off of our 2-to-1, but we try to always keep a 2-to-1 engineering ratio to stay technical and be focused on that. We have a wide variety of presence around all the different parts of the federal government. You can see there's many here, and we have many more. Just to talk a little bit about our focus when it comes to cybersecurity, we started as a data center-focused company, and we're really about doing integrated, efficient, and automated architectures, not selling boxes, not pushing just products, but really let's do an architecture, a technical design that takes all the different pieces into consideration, and let's do integration. Let's do some automation to make it work better. It really is solution design. And so we looked at the security landscape a few years ago, several years ago now, and so there's an opportunity here to help customers in the federal government do the same thing. In the past, security groups really haven't been funded very well, and so in the past it's really been difficult to do the kind of architectural design that now you can do. Funding is getting better, and there's an opportunity for security professionals in the federal government to do a much better design than they really had an opportunity to do before. And we have that specialty, and now we've been doing it for a while, where we can bring that data center design to this cybersecurity landscape. Real quickly, we have a lot of different part of the solutions throughout the entire stack. When you look at the NIST framework, which I probably should have brought that to, we have a really cool NIST framework overlay that explains where all the different solutions fall. We have everything throughout that stack and can really help anywhere there needs to be. And our focus is not just throwing more product at it, but really doing something that integrates. And that's what this particular slide is about. We've moved over the last several years from perimeter defense with just some products feeding into a SIM and trying to monitor that to continuous monitoring. Let's actually look at everything and do some analytics on it, and let's monitor what's going on. And we believe that's where most everybody is now. It really needs to move more towards consolidation and simplification, because people right now are adding a lot of products and tools, but it's really overwhelming the security professionals with so many alerts and so much information. So if we can reduce the CapEx and OpEx while we consolidate and simplify environments, make them more integrated and automated, we can allow people to be more effective and reduce labor hours and really reduce cost. In the end, the idea is to be able to add innovative solutions that can really change the game for federal agencies without adding complexity by having a truly integrated solution. And that's really designed to do stock effectiveness. Simplify, automate. Let's relieve that everyday workload that's just crushing security professionals. And so we've got a few different bullet points here. There's many ways, but these are the top ways we find to really help that effectiveness. But all of this really comes down to what we're talking about today. You can do all those things. You can have a lot of products and tools, but if you can't store the information, if you can't use the information in analytics, it's not going to work anyway. It doesn't matter. So look at the landscape for security and analytics, it's not the same as a typical enterprise application requirements. And the cost of enterprise arrays that are focused on applications is really too high for what security and analytics teams are looking for. So to point out the 4 basic requirements for cyber and analytics, you need capacity. It's big data. You need to be able to retain it, and you need to be able to compare it and use the analytics against it in a time base. And if you can't store it long enough, you can't do that. It has to be fast. You can't have all the data, but take so long to get it back or so long to do some sort of processing on it that it doesn't get to where the analytics and the cybersecurity professionals can do something with it. And density, if you do the first 2, but you have too large of a footprint for that floor space, it becomes too costly, and that goes to where you don't afford enough, because now you're talking about a large data center just to store enough and to be fast enough. And finally, and this is where a lot of people get hung up, is it has to be enterprise. It has to have reliability. So let's talk a little bit about each one of those. So capacity, the requirement is exponentially more than the typical data center applications such as email or SQL or SharePoint. It's a different type of capacity. We're talking something that really a typical storage person would look at and think, well, I can't do that in an enterprise array. The speed, it has to deliver that raw speed to the analytics tools. The machine learning requires the data to be accessible and responsive. And you can't wait for the analytics tool to figure it out, wait for it, and the security expert needs that data quickly, whether it's from the analytics system or themselves, they need it quickly, or it slows them down in doing their work and the labor it costs to do that. And then as we talked about the density, many people approach the problem we're talking about with a big data solution such as Cloudera or Splunk. And those are great solutions, and we are proponents of those solutions. But if you use those in what's called share nothing, then you're going to end up with a large footprint to do that. You end up with having to magnify 2 or 3 times the data storage of an enterprise array would to get that density to get that storage capacity you need. So there are alternatives to that, so you don't explode your cost with the floor space you need. And then finally, one of the linchpins, you really need reliability, availability, and if there's a problem, support to get it up quickly. SOCs are an enterprise. Today's world, you can't have downtime. It's not going to work if you have a breach and you can't get to your data, or you can't do the kind of work you need to do to find that. So those are the 4 basic requirements. And when you look at it, typically people are looking at enterprise arrays because that's what this is as an enterprise. But that's usually a square peg for a round hole. So your SharePoint, your Oracle, your Exchange, they're not the same as big data. They look very different. They act very different. And if you try to use enterprise arrays, you end up with a lot of problems. And it's interesting because our main solution to do that actually is one of the companies that pushed towards applications being so feature-rich in the array. So if you're faced with this choice, what is the 3 ways that people deal with it? Many people compromise on the retention and a data replay. Big problem. If you can't hold it for months and you have a breach and it goes back that time, then you can't even figure out where it came from. Budget. They spend way too much and they end up unable to spend on the kind of security tools they need because they're trying to store the data. And the reliability, availability, and support. If you compromise on that and you have a problem and you can't get it up, or you have a support problem, then you're completely unable to do what you need to do to protect your environment. So what we at SwishData really did is we looked at where is there a solution that can fit all of those things. And we have Mike Dye on from NetApp, because we found that even though NetApp, and I say back to the future here because NetApp really drove the array industry towards supporting applications better. In the past, and I go back to the Data General days before EMC bought them, arrays were just arrays. All they did was store data. They didn't do much else. Everything was at the application layer, and that is what big data does now. A lot of the functionality is at the application layer with these big data solutions. Well, in today's world, SharePoint, Oracle, Exchange, they rely on functionality inside of a typical enterprise array, and NetApp really drove that functionality and that change in the market to really cater to the 80 or 90% of what the industry needed. Unfortunately, a lot of companies never looked at, hey, there are other needs. We're leaving behind a whole group of analytics and security people that need this type of solution. So NetApp, while driving everybody towards a feature-rich array, also said, well, let's make sure that we can still cater to the people who need this other type of solution. And that's where the NetApp E-Series really is fitting that bill for this type of solution. And Mike, I'll let you take on from here and explain more about what the NetApp E-Series provides and how it fits these use cases we're talking about.
Thank you, JP. Hello, everybody. And as JP mentioned, the purpose of using our E-Series arrays is because it's about letting the application do the data services in this particular instance. And E-Series is part of our portfolio that we acquired about 5 or 6 years ago because it's a high-performance, low-cost array that gives incredibly good availability numbers. So we do have enterprise-class arrays, but we also have the E-Series arrays that give the same level of availability and redundancy, but shorten the path to data to ensure that we get the most beneficial performance metrics possible. So let's talk a little bit about what the E-Series has been able to accomplish for us. We've shipped quite a few of these things over the years. It's about a 20-year-old technology in the sense that we have centricity, and it's been around for 20 years, but we've continued to enhance it and refine it over those years. And we do a lot of interoperability testing. For those of you who are familiar with the old Ingenio product, it's something that other vendors OEM'd from us, including IBM, Sun, Dell, because it's a very robust architecture and very straightforward to deploy. But we also have a lot of application integration with it when you're not using it in this application-specific environment. But let's talk about the performance, because that's really what it boils down to in this specific use case. It's about how quickly we can get that response to your data, how well we can manage a large environment, because big data tends to mean there's a lot of it. So we've got some great customer validation. The Lawrence Livermore Labs has the ability to produce about 2 terabytes a second with these arrays, and they literally have thousands of them under management with a huge Lustre file system. So they found that it was easy to manage, easy to work with when there was a failure, and easy to deploy. As you can see, we've got some great SPC2 numbers. The SPC2 number is a bandwidth-intensive benchmark, and we're getting upwards of 70 megabytes per drive in this array and 147,000 IOPS with an 84-drive configuration. Those are fantastic numbers when you look at the cost of these arrays. So as I mentioned before, what we're really trying to drive with this is incredibly dependable performance so that we know we're going to get the same kind of performance metrics every time we run the job, that we get incredibly robust availability so that we know it's not going to go down in the middle of your run. And for other applications, and kind of for this one as well, it's very tightly integrated. So let's look at the numbers. With our 5600 series, there's 2 different controller lines. You can sustain as much as 12 gigabytes per second and 650,000 IOPS per second. And we do this by providing 360 terabytes in 4U with 5 nines of availability. And we can scale up to 2.3 petabytes. And it's built for the enterprise SAN. It's performance optimized, and the Centricity operating system is all about shortening the path to the disk from the host. So don't get in the way of that data. Just slam it down on the drives as fast as possible. So to that end, you will not see some of the data efficiencies that you'll see in other arrays. We don't try saying this 3 times fast. We do not perform deduplication on this array or compression, because that would get in the way of the performance. We let the applications worry about that, because that's the place in this environment that they should be involved. So let's look at specifically how it can be configured. You can put in 7,200 RPM drives, you can put in 10,000 RPM drives, and you can put in solid-state disks. And that's the part of the business that's growing the fastest, but we can also do it in a hybrid environment so that you can have solid-state drives as well as spinning disks in the same array and use it accordingly. You can either do a traditional hybrid environment where it does some fundamental caching where it identifies hotspots, or you can actually create LUNs that are either all flash or all spinning disk. You'll note on the right side of this slide, we have 3 different form factors that these can be delivered and deployed in. At the bottom, you see the 5612. These are the 3.5-inch form factor drives. These tend to be the 7200 large capacity drives. We've got the 5624 with 2.5-inch form factor drives that tend to be the 10,000 RPM drives. And then we have the 5660. And this is a fabulous piece of engineering because there are 5 trays that can slide out that have 12 drives per tray. And you can slide that tray out while the drives are spinning and serving data. It's designed for that operation, and so all the drives are hot pluggable, but you can get 60 drives in 4U of rack space. Incredible density. At the low end, or our volume space, we have the 2700. As you can see, it still gets pretty good throughput, but it does suffer a bit in terms of IOPS. But if what you're looking to do does not have the same performance requirements as the 5600 can maintain, this is a great option because it still allows you to grow fairly substantially, still get great throughput in terms of bandwidth, and get the same availability as you get with the 5600. Here's the performance, the configuration specifications for this. You can still put together a hybrid environment. You can still put together these things in the same form factors that are available with the 5600. It's just that there are fewer cores and lower performing CPUs to make this happen. One thing I should note is that all of the data is accessed on these arrays in a SAN fashion. So it is either fiber channel or iSCSI or SAS. This is not a file type of environment. That is what our ONTAP FAS systems are used for. As I mentioned, this is all about performance, so we don't let anything get in the way. To sum it up in terms of the availability features, always have dual active controllers. We have dual active I/O paths to every drive, and there's no single point of failure in the entire environment, so there should be no scheduled downtime. If we have to replace a controller or a drive, we can do that without losing access to the data. And we can support either RAID 0, RAID 1, RAID 5, RAID 6, RAID 10, or something that we call dynamic disk pools. And with dynamic disk pools, what we do is we share the RAID or protection across multiple drives so that recovery times are dramatically enhanced. And that's what I wanted to talk about regarding the hardware.
How does this solution scale? It appears to be individual arrays.
I'll let you take that, Mike.
Yeah, thank you. It is individual arrays, but what you can do is scale horizontally with these in that they can support a large number of drives and still get that same performance metric. If you need to grow beyond that performance metric, then we would sell you additional controllers, and the application would ensure that the data is placed properly to drive the performance numbers that you need. But since these things can scale to multiple hundreds of thousands of IOPS and 12 gigabytes per second, it's pretty hard to outrun one of these things.
Yeah, I think, Mike, that's an important point to make, is that because we're talking about arrays that are all about performance, and we're using a lesser expensive array when it comes to that performance, we're taking away the features that normally would tie them together in some of the application-specific solutions. What now we're relying on the analytic or the cybersecurity tool to tie them all together just by presenting a lot of LUNs over Fiber Channel or iSCSI, right? So it's a block-based architecture which allows you to create that. Doesn't really matter how many arrays I have. All it matters is I present enough storage for you to use. And that's the difference when we're talking about this kind of solution versus now we're talking about SQL or SharePoint. They can't handle you spreading across multiple arrays in that same fashion.
Precisely.
Great, thank you. Katie, do we have any audio questions at this time?
We have no audio questions.
All right, I do have another one. It's why external storage versus internal storage to the application nodes?
That's a great question. Mike, you don't mind if I jump in on that one?
No, you go right ahead.
Yeah, one thing that often comes up in this kind of solution, and this is an analytics question usually surrounding the shared nothing when it comes to Hadoop. People talk about, hey, I want my internal storage because I get the performance of having that storage local to my CPU. That was the whole goal of the Hadoop shared nothing. The way that this is achieved in this solution is that we are presenting the storage without networking in between it and the system. So the system is directly connecting the storage, not through a switch, not through the typical networking, and sometimes it's Ethernet. What you'd want to do is you would want to connect it directly, and therefore the system does not have latency. And what you gain out of that is a much smaller footprint of storage, and you actually get better performance, which is counterintuitive to most Hadoop-oriented people. You actually get better performance because you're able to provide data in a striped, better IOP, better throughput than usually internal disks can provide.
Yeah.
Go ahead, Mike.
No, I was going to say most internal and integrated drives are slower drives to begin with. So when you do that, you're using lower quality drives, and you're doing it over a slower connection mechanism as well.
Right, and you tend to have less enterprise drives in those situations. It doesn't have to be, but if you do use enterprise drives, you end up paying a lot more money, and it starts to kill that cost reasoning to do it, right? So you start to lose, and this is right where I was going when you started talking, you start to lose that enterprise redundancy, that enterprise reliability when you start using cheaper internal drives that fail more often. I like to point out the fact that the typical Hadoop that uses shared nothing, let's look at Google in particular. What Google does to keep their costs down is they hire a Stanford intern at almost no money who's a smart guy, but really honestly is almost a guy just rolling around on skates, just swapping out drives in a huge data center where drives can fail, but it's okay for them to have that happen because they can hire cheap labor to run that around. The government can't do that. You can't just go get some low-cost guy to change out drives for you because they're failing in a very large multiple petabyte infrastructure. And so a lot of enterprises don't have that kind of system or setup that some of these shared nothing have available to them. And I think it works for them, and I don't want to down that, but in a government-type enterprise, it just doesn't work, and therefore you need the reliability of an enterprise storage, but you need it to be designed properly and be the right cost.
The other point I like to make with this question, JP, is that with something like Hadoop or other clustering multi-process analytics applications, they require you to have usually 3 copies of the data. And they deploy it across the Hadoop file system. And what we can do is we can do this in RAID 6 or RAID 5, still get incredible performance and not cause you to have all those copies of your data. And you end up saving a lot of money because you've got a shared storage environment that you can connect to, whether it's via SAS, whether it's via iSCSI, whether it's via Fiber Channel, and look just like it would normally with Hadoop, but you only have to keep a RAID parity protected copy of that data. You don't have to make 3 copies of it.
Well, and it allows you to do things like the disk support structures that a lot of the government has with enterprise storage vendors now, where you can do swap drives really easy. You have a lot better infrastructure to deal with it.
Yep. Agreed.
Katie, do we have any other Q&A from verbal, or do we need to go back to the Q&A from Jamie?
We do not have any audio questions at this time.
Okay.
Jamie, did you have any more Q&A?
Yes, I do. Next one is, why would you choose spinning disk for analytics and security rather than flash?
I'll let you take that one because you talked a little bit about flash, Mike.
Well, flash is a great environment for low latency type of I/O. So we see a lot of flash in database operations, reservations, places where we place an emphasis on the number of IOPS per gigabyte of storage that is installed. And the funny thing is, if you're doing truly bandwidth intensive workloads, even 7,200 RPM spinning drive, it's like putting a needle on a record player. When you do that, a lot of data spins under that needle. Just like in a 7,200 RPM drive, a lot of data spins under that read head when you do that. So we find that it doesn't always pay in high performance or analytical situations to have a full SSD environment because of that. You just get great performance with the spinning disks. But what we also find is that you might have some metadata, you might have some low latency requirements, and then we can fulfill that with a hybrid environment where you have a little bit of flash and a little bit of spinning disks, and you put it all into a big pot, and you stir it up, and you get a really clean, well-operating environment.
So I want to point out two things, Mike. One, you mentioned in your presentation that you can do that, where you can have some flash, some spinning disks. Like you said, when you're dealing with metadata, that really is the crux of the performance, and it does have the pattern that a typical database would have, right? So there you definitely would want to have that kind of performance patterning. So I can see where you do want to have a hybrid, but the other part of that is these E-series could be all flash if that's necessary.
Sure.
Right? So you could do all flash if that's what you're looking for. But I think a couple things come to light in that, and one is that you probably couldn't get the capacity at the cost you needed doing that. And two is that flash is really about churning I/O. And when you're doing this kind of analytics, sometimes it's about streaming just a lot of data. You might have a stream of data, and flash may not actually perform the same as a spinning disk when you put a lot of disks behind it. So you might actually get better performance streaming that out of a large disk array for the kind of data when I'm going to play a conversation that is a large conversation with a lot of data over a period of time. So then it becomes a continuous stream where you may actually get better performance in a stream from a spinning disk.
Yeah, it's interesting when you look at these things. Take a look and see if you're able to saturate the channel that you're connecting with. If you're able to saturate the channel you're connecting with, then you really don't need flash, because if you can saturate it with spinning disk, why would you put flash in there just to saturate it with a more expensive mechanism?
Right. But again, if flash is the right solution, and depending on what it is, it could be. You could do all flash in an E-series.
You can.
Okay, great. Katie, do we have any questions in the audio line at this time?
There are no audio questions.
It looks like I have another one. It's a follow-up question to the last one. Why would you use specific storage for the analytics and security and not use the agency's already established enterprise storage? Wouldn't that be an easier method to maintain it?
Mike, I'll let you take that one.
Well, you certainly could, but I think it's a question of where you're going to save money, whether or not it makes sense to tap into that existing resource and potentially take performance away from your existing enterprise applications. It's a big question of utilization and avoiding becoming the noisy neighbor. So if you go out and use your enterprise storage and someone else is using it, this can be a pretty intensive workload, and it can actually take resources away from those enterprise apps that you're currently running. And it's probably fairly expensive storage, where we could put together a solution with the E-series that provides a lot of performance and a small form factor with a very low cost. It ends up being more cost effective than using your enterprise class storage, because you now have to add drives to that to get the capacity you need, and again, you're taking resources away from your other applications. So that's why we tend to see specific storage sold for these kind of solutions.
And I'll add one more thing to Mike to that. What we're starting to see where storage becomes so important as retention and long-term ability to do patterning becomes important is that provisioning of what a storage team in a typical enterprise owns versus a security team sometimes owning it themselves becomes a little bit of a problem because they're going external themselves and they say, oh, we want to provision this or we want to manage this, we want to do this. So it becomes a question of who's going to run it, how you're going to run it, and who do you have to rely on. If you're in a on-prem, truly cloud environment where it's automated provisioning, it's not a problem. I don't see a whole lot of that right now. Most are not all the way automated to an on-prem cloud. So it becomes a problem of if the ownership is with the storage team who's focused on enterprise applications as they should be for Exchange or SQL or Oracle or whatever those things are, they may not get what they need as quickly as they need from the way the infrastructure is set up. So sometimes the security team owning it is better for them and their ability to operate. Not always, but sometimes it is a consideration too.
Okay, great. Katie, do we have any audio questions at this time?
There are no audio questions.
Okay, I do show another one came in. Question is this running clustered on tap like the FAS systems?
Actually, no. It's running something called Centricity. So with our portfolio, we just acquired another company called SolidFire. So we have three primary storage products today. We have SolidFire, which is great for service providers and people who want to take on the web scale class data centers and deploy things as if they were their own cloud. We have the FAS products, which featured clustered data on tap, which has all those enterprise features that we talked about in the beginning that can do great things for databases, have great application integration, but because of that, they don't necessarily fit into the high-performance model, which is what the E-Series is all about. It's about high performance using the Centricity operating system to get that path to the data as short as possible. So it is not on tap.
This goes back to what we talked about, where what you're looking for is different than what clustered on tap is really delivering. Clustered on tap is really delivering to a different type of use case, where this is focused exactly on delivering on those requirements that an analytics or a security team is looking to do. Clustered on tap just changed the world in enterprise arrays over a period of 15 years, 20 years. And it took a long time for people to get the idea that what ONTAP and clustered ONTAP brings to enterprise applications is game-changing. And everybody followed suit because NetApp led the way on that. And that's good. The problem was that because everybody followed, those features built into the arrays necessarily added cost. And that's where the E-Series really fits differently, right? It's a different type of solution for a different type of need.
Well said.
Great. Katie, do you have any audio questions at this time?
There are no audio questions.
Okay, and I show no more questions on my end.
Well, thank you very much, everybody. Appreciate your time, and we'll give you 20 minutes of your time back from the hour we had allotted. I believe that we will be following up with this, so if there's any more questions, please let us know, and we'll do our best to answer those.
Thank you very much, everybody. As JP said, feel free to follow up with any questions that you couldn't think of during the call. We'd be happy to help.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating. You may now disconnect.